So, hello everyone. Thanks for joining us. This is the SIG Scalability Deep Dive session. I am Shyam. I've been associated with the project for a little more than 2.5 years, and I focus on scalability and performance aspects of Kubernetes.
I'm Wojciech. I work in Google, working on Kubernetes for the last 4.5 years-ish, focusing mostly on scalability and performance since almost the beginning of then. So, yeah.
Okay. So before we start, just so we can tune the focus a bit, can we have a quick show of hands of how many in this room are end users of Kubernetes? And how many are developers of Kubernetes? Okay, so it's about pretty much 50-50. Cool. So we plan to keep this the presentation part short, so we can have enough time towards the end for more discussion and like just open the stage for discussing about any pain points you might have or any feedback that you want to give with respect to scalability. Okay, so first some small background. Any work that we do at SIG Scalability kind of falls into, at a high level, one of these categories. So we are responsible for defining and driving the scalability definitions and goals for the Kubernetes project. So this involves building an understanding of what scalability is and building an understanding of what metrics we want to look at and what are the long-term and short-term goals with respect to scaling better. The next one is monitoring and measuring the performance aspects of the system. So we actually continually monitor what different kinds of metrics in our system and see how they're changing over time. We look at trends and patterns. And often based on that, we end up identifying some of the things that we want to improve with respect to performance and scalability, which is where we come into this coordinating and contributing part. We do some improvements ourselves, and some of the improvements we basically get done with help from other SIGs. The fourth category, this is the other side of the scalability story, where we are continually persevering to try to protect the project from scalability regressions entering, and this happens all the time. We have scalability regressions coming in, and we are like actively battling those. The final one, which is something we're always doing in the background, is consulting the community with respect to scalability and performance topics and providing reviews and just educational talks and blog posts and stuff like that. So one particular thing I'd want to specifically call out is please don't confuse SIG scalability with SIG auto scaling. Both of them have scale in common, but that's pretty much everything that's in common. And SIG scalability is about how much is the system able to scale when we are throwing enough resources at it. So we are really talking about like the absolute hard bounds for us. And auto scaling is more about how dynamically the system is adjusting to load. And yeah.
Okay, so scalability definition and goals. This is a topic I'm not going to talk that much today. I have a separate presentation tomorrow fully about this topic, so I will focus a bit more on just like some kind of a teaser for that. So basically, defining scalability is very, very complex topic. How we are doing that is that we are basically formulating a set of SLIs and SLOs, service level indicators, and several service level objectives. You can think about them as like metric, SLI being a metric, some metric, and SLO being some metric with a threshold, basically. And what we are doing is like we are defining the scalability by defining a set of those SLOs, and we are saying that your cluster scales or a given setup scales when those SLOs are satisfied. So a little bit of history here, like in 2015, we literally started with the formulation from the above, which is like with two SLOs, like 99% of API calls is less than 1 second. or finish within 1 second, and 99% of pods start within 5 seconds. This definition has a lot of drawbacks. I'm going to talk a lot about those tomorrow, so I'm not going to get into to details today. But we went quite a long road, even though like it's way more in front of us. But currently, we significantly or visibly improved those SLOs. The formulations here on the slide are just an overview. It's not like how exactly those look like today. There are a bunch of details there. But at the high level, they looked pretty similar, but they are much more precise, and we ensured that like all the people understand them the same way, not that as at the beginning, like I bet that if I took any of you and myself, we will understand them differently. There are also 5 more SLIs and SLOs defined and approved, mostly in the networking area, and one in storage area. They are still like work in progress ones, because although we agreed on the exact formulations and we discussed them with users that those are the things that they really care about, we still don't measure them properly. So we want to first measure them, like see where exactly we are, tune the exact threshold, and only then make them really official ones. Yeah, so as I said, like I will talk for pretty much half an hour about this like tomorrow. So if you are interested, I recommend this talk. There's also like based on those SLOs, we introduced this concept of like scalability envelope. So scalability is basically not a single dimension. It's not only size of the cluster. It's also like number of pods in this cluster, number of namespaces, number of secrets, and many others. There are dozens of those dimensions. And basically what we are saying is that if you we are building this concept of scalability envelope in a way that if you are within, in all the dimensions, if you are within this envelope, then we guarantee that that the SLOs that we have will be satisfied. And there was also a talk by Shyam and Wojciech on last KubeCon that was presenting like what is the characteristic of this envelope. It's not that the dimensions here are independent. It's pretty complicated. So also like where are we with respect to each dimensions and stuff like that. So if you are interested in that, I also recommend watching this one. Yeah.
All right. So once we've defined and identified our goals and definitions, the next part is to actually go ahead and monitor and measure various metrics of our system. And this is where we have a bunch of infrastructure that we built, especially for scalability tests, and some really good tools to help us do this. So I'll go through some of those. The first one, of course, is like automating all of our scalability testing. So we've included scalability testing as part of the project CI. So now all the changes that get into the system, all the changes that get into the Kubernetes repository are being scale tested, both as pre-submits and post-submits. And this is a really big dashboard which has grown over time, especially in the last few months. We've added many different jobs, and these jobs are like at different scales. They start from 100 nodes and go all the way till 5,000 nodes. And we have benchmarks running, we have simulated cluster tests running, which is what we call as KubeMark, and some experimental tests. And these tests are basically running as post submits and periodically, and we are publishing the metrics, and we're basically publishing the metrics from those tests publicly. You can go to that URL. It's really in small font, but you can go to that URL and you'll find a bunch of very interesting metrics. So these are from our scalability tests, and things like API call latencies, pod startup latencies, scheduler throughput, resource footprint, CPU memory usage of various components in the control plane are all shown here. The next one is gathering of profiles. We also do this. I think right now we do this only for API server unless it changed recently.
It's changed. Yes,
changed?
we are gathering from all master components now.
Wow. Okay, that's awesome. So yeah, so we get CPU profiles and memory profiles, and we from time to time this gives us very useful signal in knowing where are we spending most time using up CPU cycles in these components, and where are we doing some of the biggest memory allocations. And sometimes this helps us catch bugs, and sometimes this just suggests general improvements that we can do based on these. Yeah, this one is a big one. So Cluster Loader is a tool that it's kind of a favorite pet project for SIG scalability, and we've been working on this for a while. It's finally in really good shape now. So I'll go ahead and ask you guys to try it out. It's a tool to very simply define scalability tests, like declare scalability tests in a declarative way and run them against your cluster. So I would avoid going too much into the details of the API, but at a high level you can see this is how simple your configuration can actually look like. So there are some constants you begin with defining at the top, which is the name of the test and the number of namespaces that you want to use for your test, and a tuning set which tells at what is the pattern by which you want to generate your load, like at what rate. And so for instance, in this case you can see that we're defining a uniform QPS of 5. That's how we want to generate the load. And then there are these steps which are basically a series of steps which every step is either a measurement or a phase. So measurement is where we actually go ahead and start some measurement, or actually go ahead and try to obtain some metric. And phase is where we actually where we actually create the load according to the tuning sets that we specify above. So in this particular case, we just start a simple measurement that looks for your pod startup latencies. It calculates your pod startup latencies, and then we go ahead and actually create so many replica sets with so many number of replicas across your namespace. And then finally you go ahead and again have another measurement where you stop the measurement that you earlier started and summarize the results. So yeah, so this is a really cool way, and we really encourage you guys. I mean, you might be contributors or you might be end users who just want to try out running scale tests against your cluster, so you can use this tool to run this. Yeah, this is the very latest improvement, I think, in the last week or so, where we are actually adding metrics from our scalability tests from the duration of the test itself. So earlier, the thing that you saw in performance dashboard, that is how these metrics are changing over test runs over time. This is how the individual metrics like API server memory usage or API call latencies and stuff like that is changing along the duration of the test. So if you use this in combination with cluster loader, that can give you pretty good insight into the performance of your cluster and what sort of bottlenecks you might be running into. All right, okay, am I covering this? Okay, so this is the third part where after doing the measurements and monitoring, we identify some of the areas that we want to improve upon. This is driven both by the metrics that we got from the previous step, and also based on user feedback, like what users of Kubernetes are running into. And scalability is a very horizontal effort because it is something which is defined by many different verticals: networking, storage, API machinery, and a lot of stuff. And so this inevitably means that we need to operate in two modes. One is where we are making the improvements ourselves, but because the domain is so wide and there are so many verticals included, we often also collaborate with other SIGs and get some of these improvements done. These really they vary from really small fixes to big architectural improvements. Yeah, so that's what we have in this category. So some some of the recent improvements that we've been making in SIG scalability and along with other SIGs. I mentioned here all that I could remember. There is a talk tomorrow that I'm giving at 3:55, which is going to discuss these in more detail. So I'm not going to give much spoilers, but I can maybe just explain at a high level what these are. So we made node heartbeats cheaper. So basically, we are reducing the amount of space usage in HCD that is used up just by node heartbeats.
By the way, this was mentioned on yesterday's keynote by Janet.
Oh, it was? Wow, okay, I missed that. That's amazing, yeah. And props to Wojciech because he was driving this. He wrote the KEP for this and he was driving this whole effort. And it's a really good KEP and a very well thought out and nicely written. And I totally encourage you to read it from our enhancements repo. The next one is we moved, this is a little bit older, I think 2 or 3 releases ago. Again, I won't give too many details about this, but we moved kubelet from watching for secrets and from polling for secrets and config maps by making periodic get calls to watching them, which basically reduces a huge number of API calls in large clusters. Another one is new API for events. At some point, I'm sure many of you would have run into issues with events API and how they're firstly like not super useful for any automated consumption and also like general spamming of the control plane with events. So we are introducing a new API for that. There have been some improvements with scheduling algorithm. Yeah, so the main one is basically that we now allow for selecting only ranking only a subset of nodes instead of like evaluating the priorities for every single node that pass the predicates. This helps in large clusters with respect to scheduling throughput. And the last one is IPVS going GA, which was also a while ago, but this helps us basically improve our networking performance. Yeah, so I encourage you to attend my talk tomorrow if you want to know more about this.
Yeah, so protecting from regressions. Like, obviously, one thing is to get to a given scale. The second thing, like, but it's one thing, but the second thing is basically to not regress from a given scalability that we already achieved. And the most important part in that are obviously tests. We have basically 2 main tests now that we are running, which is far away from where we would like to be. Part of the reason for that is that our tests were super complicated. It was like super hard to understand it, even though we actually wrote them, or maybe because we actually wrote them. So I was kind of resistant to extending them farther before we had cluster loader. Now that we finally switched to cluster loader a couple months ago, like 2 months ago or something, we will be working on extending our test scenarios to way more dimensions, way more things so that we will know where exactly we are in some dimensions, and to ensure that we won't regress in any of those. Those tests are, as Shyam already mentioned, like we have pre-submits. Currently existing pre-submits are like 100 node test and 500 node kubemark test, which is like this simulated cluster. Those are running on every single PR. And those are basically responsible for catching probably something like 60 to 70% of regressions based on like the investigation that we did where from the times when we didn't have any pre-submits. But still, like some regressions are happening, and those are being uncovered by the post-submits that we are running. We are running, like the main post-submits that we are running are like 5,000 node cluster, and running them both scalability and regular correctness tests that we are running on every single PR. And those are actually also release blocking. So to talk a little bit more about regressions, like last couple weeks were really terrible. Like we had at least 7 regressions that I'm aware of in the past couple of weeks, and those are like ranging from very small regressions, like we, for example, increased the amount of logs in kube proxy by like 3 orders of magnitude, and that like started completely breaking the nodes, and like everything started behaving really badly, to regressions like caused by the update of Go that we were using, like Go 1.12.0 had a significant performance degradation connected to how they were allocating the memory. It's actually not the first time when Go broke us. I remember that at least like Go 1.8 and Go 1.5 broke us too in the past. The difference is that when they broke us with 1.5, which happened in 2015, they said, we don't care. And now they really like dropped many things and were working very hard with us to ensure that we understand what is happening exactly and that the problem is fixed. And this is now fixed. So yeah, so the regressions that like are happening pretty much everywhere, like from Go that I mentioned via also operating system. I remember a bug when we bumped a kernel and it started using a different IO scheduler. And because of that, like when we are using 2 disks, one for logs and the second for etcd data, like they started interacting strangely, and like it completely broke also the performance of APIs, or of etcd rather. But yeah, and there are obviously a number of regressions in different Kubernetes controllers, and pretty much all of them. I think we observed in all of those in the recent probably half a year. In all of those, we had some regression. So yeah, so I think that the goal here in this area for the next months is to significantly improve our testing coverage and ensure that first we will be able to catch potentially more regressions. Some of those we don't really know if there can be some regressions that we didn't even catch. And the second thing that I think is a huge goal here is to significantly reduce the time that our tests take, so that we will be able to run them much more often, and hopefully, that's my real hope, that we will be able to introduce some post-submits, hopefully, for them, so that we won't need to debug like 5 piled up on each other like regressions, which is like a nightmare to debug. And the last thing that we are doing is like consulting and coaching the community around like scalability. This is happening via different channels. I think probably most is happening on Slack, but there are a bunch of also things happening on GitHub, or like on some specific PRs or issues directly. There are some discussions happening also during the SIG meeting, but yeah. There are a couple things that like we probably would like to do here also very soon. One of the things is that we had some documentation for best practices, what you should do to avoid introducing regressions. This is like very old. This is not widely known. I would like to, or we would like to make that, like refresh that significantly and ensure that it is like much better known among all community members that are contributing to Kubernetes. And yeah, I think that's what we had for today. So, are there any questions?
Okay, bunch of those. I think
as we scale up the number of resources we have and make the clusters larger, we face significant memory pressure on things like the Kube Controller Manager and the scheduler. Are you guys doing anything specific to address those?
I agree. It's becoming a problem. It still isn't the most. It still isn't the thing that we are hearing the most from people. So we are not doing that much, to be honest. One thing that happened recently is that with Go 112, like the resource, or in particular memory usage, like the metrics dropped by something like 3x. So I'm not sure if you've already tried that. That like is huge improvement. So we probably should start looking into that, but there are still like so many things that people are, or users are complaining much more about it, so that we didn't really have time to look into that. Like it will come at some point, but to be honest, I doubt it will happen this year. But obviously, if like anyone would like to contribute, we are more than happy to help with like consulting it or reviewing or whatever. I think there was some other question there first.
Hi. So one question is, are you evaluating the problems that can imply the container runtime? Because I didn't see in the slides.
So now we are basically focusing on more like cluster level problems. The container level, or I would call node level problems that are not directly affecting the cluster as a whole. It's more like driven by SIG node.
Yeah, so I want to add one thing here, that there is another version of perf called node perf, where I think SIG node runs node level benchmarks and performance tests to benchmark like Docker, container and containerd and stuff. So.
And yeah, apart from that, I remember in previous versions the bottleneck was etcd, in terms of the watchers and stuff. What do you see now that is the bottleneck of any component that you see that might become that? I know that HC has been involved that in performance lately, so yeah, I wanted to know that. And maybe I do already another question, or if you want, you can. Which kind of pods do you run on the test? Can you customize with this version V2 of the cluster loader to specify the image that you want your pods to run, or yeah?
So to the first question, like etcd improved a lot. There are a couple things that we are planning or are planned for 3.4 etcd version coming up in June or July. The biggest one I am aware of is like concurrent reads from etcd. So etcd is not that significant bottleneck that it used to be in the past. It's hard to point one exact thing that is the biggest bottlenecks, because it like highly depends on what exactly you are doing. Like I can imagine it being a scheduler if you want to like schedule very small, short jobs, not requiring any volumes, any specific networking or anything like that. I can see that being like API server. I can see that being like a specific controllers. Like it really depends. Like I think we have work to do in every single component, but it's really a matter of like prioritizing what seems to be the biggest problems for the biggest group of users.
Do you want to say it to the mic? Because you recorded.
So if you also try to evaluate the performance when one node goes away, how the system reacts under the pressure, that. Yeah.
So this is something we are slowly starting to do. We are not there yet. Like one of the things that is like in progress is like evaluating performance of cluster autoscaler, which kind of, it's not exactly this, but it's like kind of step towards that direction. But we also introduced a concept of like chaos monkey to cluster loader, which is exactly doing, which is exactly randomly killing some nodes. I think it's enabled in the smallest tests now, but I can't remember from
I was seeing a new job that you added called Node Killer or something like that for 100
I think we wanted to enable it also by default, but maybe that didn't yet happen. But yes, we are aware of this problem, and yes, this is going to happen. And I think you had another question that you already asked, and I forgot what it was. Okay. Oh, the type of a pod. Yes. So basically, in cluster loader, you can run whatever you want. We are basically still running only the sleep pods or the pause pods. But yes, it's basically from. It's basically what I mentioned before. Like we're kind of not doing any significant changes to our test and not extending them because I almost was not able to understand what our tests are doing like in the previous version. So yeah, so this is definitely going to happen.
Is there a place I can find the scalability limits, not scalability limits, but count limits of stuff like config maps, secrets in a particular namespace?
So in the last slide that we showed,
so you mean in the running cluster or?
Config maps and secrets may not get rid of them. Is there like, we have limits on nodes and stuff like that that's documented or studied, but other resources that you create Kubernetes objects, is there any place we can find limits on that?
So there was a presentation that was mentioned in those slides, like given by Shyam and Wojciech on the previous KubeCon, when they were discussing many of those limits. There is a page in community repo in SIG Scalability directory where we started documenting it some time ago. To be honest, it's pretty outdated, but it's like many things are not fully filled there, but it's probably like a place where you may also want to look at. And like we definitely would like to finally have it updated. This is the question that I'm hearing a lot, and this is something we definitely would like to address soon-ish.
So with just a couple of minutes left, maybe couple of questions we can ask to you guys. Is someone from you like trying out to push some limit a lot, like running really big services or running large number of pods? Or okay, I see Anjay raised a hand. So how many pods did you run, Anjay? Okay, that's a lot.
That's cheating. You weren't running it yourself. Okay, any other questions? I think we have like 3 minutes more or something.
All right.
Okay, if not, then thank you. Thank you very much for coming.